Hey guys, it's Miss Hagan and welcome to physical science video about Charles Law. So today what we're going to be talking about, like I said, is Charles Law. And Charles Law has to do with gases. Fun times. So Charles Law is named after a man who was a scientist. The very stereotypical view of a scientist. And yes, he was a white man as well, and old and kind of saggy. If you go look at pictures of him, he's definitely got the double chin happening. Nothing bad about the double chin, just saying, typical idea of a male scientist. So anyways, Jacques Charles was a Frenchman, and Jacques lived a while back, okay, like a good while back, before photography, okay? And Jacques was really into hot air balloons. Like, I mean, he was pretty obsessive about hot air balloons, almost to the point where it was like, yo, Jacques, you got some issues, dude. But anyways, Jacques Charles was really into hot air balloons, and he wanted to know how hot air balloons work. Why is it that I can go up in a hot air balloon? Like, really, a balloon can carry me up into the sky. How does that work? Well, Jacques did a lot of research, and he looked into a lot of different things, and what he found was that there was a relationship between stuff working with gases that allowed this to work. Okay, now if you guys remember, there are three things that really influence gases and their behavior, and those three things are this. We have volume, temperature, and pressure. Okay, now Charles found that volume and temperature were involved in making a hot air balloon work. And what he discovered was that as the volume increases, the temperature increases. Okay, so think about if you were to put a balloon in some boiling water, or you put a balloon over the top of a flask and heat it up, the steam from the water is going to cause the balloon to expand. Okay, so as this water has gotten hotter, the volume of the balloon expands, so they're both increasing. But he also found that the inverse or opposite is true as well. That as volume decreases, temperature decreases. Okay, so they're doing the same thing. As one increases, the other increases, and as one decreases, the other decreases. Okay, now we call this relationship a direct relationship, or we say that they are directly proportional. Okay, so as what one does, the other one does. So this is a direct relationship. So direct relationship, or we can say that they are directly proportional. Proportional. Okay, I have a hard time with that word sometimes. Okay, so direct relationship or directly proportional. Now, we are able to show this through two different ways. We can either show it through a graph, or we can show it through an equation. So I'm going to show you guys the graph first, because people tend to like graphs a little bit more than math equations. Okay, at least I do. All right. So on my y-axis, I'm going to have v, and on my x-axis, I'm going to have t. Now for this graph, you could have them reversed. It doesn't really matter on this graph. So since he found that these two were doing the same thing, we also discovered that this means they have a linear relationship. So if we talk about math, we think back to math, and I know, just bear with me, I know math sometimes really sucks, but sometimes it's really awesome, okay? Linear means a straight line, okay? Bam, there's my straight line, okay? And it continues on forever, okay? So the way I read this graph is like this. I'm going to put a dot on here. I'm going to put one down here, okay? If I was to do a dotted line down, I'm going to say that my temperature has increased. It's a big number, okay? It's bigger than 0. And same here. My volume is large as well, so they are both large. But if I move down here, and let's put a dot down here, and I go like this, okay? My temperature has shrunk, it's gotten smaller, but so has my volume. So they both decrease and both increase together. So that's how we read that graph, and that's what that graph is telling us. Now, I told you guys we could do one as an equation as well. So when we do it as an equation, we're going to say V1 over T1 equals V2 over T2. Okay? Now, if we had to solve this problem, which in physical science, I'm not asking you to solve this problem. Chemistry, you totally are going to have to. But if I had to solve this problem, then I would have it where you would cross multiply and solve for x. Okay? Now, one really important thing that I need to tell you about this is that Charles' law does not occur unless something is kept constant. So if we look at our equation and we look at our relationship, we've talked about volume and we've talked about temperature. Have we talked about pressure? No, we haven't. So pressure must be kept constant for this to happen. If it's not, then you're going to have some issues. Okay? All right, so to summarize real quick, Charles' law involves volume and temperature.